What's up, guys? This is Matthew Burns and welcome to your second tutorial on how to build an 8-bit computer entirely out of individual logic gates. In this tutorial we're actually going to be constructing the ALU we learned about in the last tutorial, and to do this we're going to need 3 different types of logic gates. The exclusive OR gate, and for that I am using a 74HC86N integrated circuit chip. It has 14 pins, I believe, and pin 14 is for power, pin 7 is for ground. There are 4 different logic gates in this, and each one has 2 inputs. Here's the pinout. And then for the AND gate, I am using a 74HC08N. It is also 14 pins. 14 is power, 7 is ground. It has 4 different logic gates, and each one has 2 inputs. Exact same specs. And I'm going to have to pull up a pin out of that, so here it is. And then for the OR gate, I have a 74HC32N. It's exact same specs, 14 pin, 14 is power, 7 is ground, 4 circuits, 2 inputs. And you're also going to need a breadboard and some wire, and this most likely isn't going to be the power supply for the computer once we finish building it, but just so we can test this out once we finish building it, you're going to need a 9-volt battery snap connector, a LM7805 voltage regulator, and just 2 capacitors. These are 0.1 microfarad capacitors I'm using. And we're also going to need 3 10K resistors. Now, you might or might not need these once the computer is totally built. I haven't planned out the rest of the computer yet, but I'm just kind of building as I go. So, for testing, though, once we get one full adder complete, you're going to need 3 10K resistors to test that. So first, let's plug in the chips and set up the power supply. The orientation doesn't really matter as long as the connections are correct, but how I did this is I have the bottom of the exclusive OR gate chip on pin 60 of the breadboard, and this is the top up here if you can't see, with 7 spaces in between. I have my AND gate, my 74HC08N, 1, 2, 3, 4, 5, 6, 7, so I'll place it here. And then 6 spaces up from that, I have my 74HC32N OR gate. So let's see, 1, 2, 3, 4, 5, 6, I'll place it right there. Now we're going to need 6 wires, 3 for power, 3 for ground. And like I said, or I mentioned when I told you what the chips were, on all of them pin 14 is power, so make sure you connect those to power. Okay, you might want to skip past this part of the video if you know what you're doing, because this is really simple and it's taking me a long time, which is annoying for me too. So come on. Finally, that one was annoying me. Okay, now you're gonna want to connect all of the pin 7s to ground. Okay, finally, now that's done, we can get to the fun part. Actually, first, remember in the last tutorial when I told you how the first input of the first exclusive OR gate goes to the first input of the AND gate, or one of the AND gates? Actually, like, that orientation isn't too important. It doesn't matter because the exclusive OR gate doesn't differentiate between what's its A input and what's its B input. As long as one or the other input is high, not both, there'll be an output. And same thing with the AND gate, as long as both are high. So does it matter which one's A and which one's B, because they're both high anyway. So the way I'm wiring this up might not follow the schematic exactly in terms of which input's connected to which input, but some of them do have to be exact. Like the carry-in goes to the second input of the second exclusive OR gate. The carry-in cannot connect to the first input of the second exclusive OR gate, which is the output of the first exclusive OR gate. So if you want to follow along exactly, or if you want to construct this on your own, I'm going to record this, so feel free to watch and follow along if you want. What I did for this, though, is I actually connected the first input of the exclusive OR gate to the second input of the AND gate. So pin 1 of the exclusive OR gate integrated circuit goes to pin 2 of the AND gate integrated circuit chip. Now pin 2 of the exclusive OR gate goes to pin 1 of the AND gate. And then I have the output of the first exclusive OR gate go to the input of the second exclusive OR gate, or the first input of the second exclusive OR gate. So I just have a little jumper wire here going between pin 3 and 4. And now I have pin 4 of the exclusive OR gate integrated circuit chip going to pin 5 of the AND gate. I believe that's this wire here. I cut these wires ahead of time. I just can't figure out which ones go where. That's the one. And then pin 5 of the exclusive OR gate goes to pin 4 of the AND gate integrated circuit chip. And then the last things we need to do are to hook a jumper wire up between pin 3 of the AND gate, so the AND gate output there, to pin 4 of the OR gate chip, so pin 3 of the AND gate chip to pin 4 of the OR gate chip. And then we're going to need to hook a jumper up between pin 6 of the AND gate chip to pin 5 of the OR gate chip. And the full adder is constructed. All we need to do is hook up the power supply and plug in some LEDs with resistors, of course, to test the sum and the carryout. By the way, the sum is pin 6 on the exclusive OR gate chip, and the carryout is pin 6 on the OR gate chip. So I'm going to hook the power supply up, and then I'm going to hook the LEDs up without recording, so you can go ahead and do that part on your own, and I'll be right back with you in a moment. That is, of course, after I finish the power supply. So all I did was I plugged in the LM7805 voltage regulator to 3 empty pins. I plugged the capacitor from each pin, the left and right, to the ground, which is the center pin. And then I'm hooking the power up to the left pin and the ground up to the center pin. And then our voltage output, which should be almost exactly 5 volts, will be the right-hand side pin. So we're going to hook that up to this bus here, and hook the center pin, which is ground, up to that bus. I'll do that, plug in the LEDs, and be right back with you. Okay guys, I'm back. I did all the things I said I was going to do. I hooked up the power supply to the bus, and I hooked up the LEDs to pin 6 of the exclusive OR gate, which this LED is my sum, and then pin 6 of the OR gate, which this LED is my carryout. Now, these 3 wires here I'm using are to plug into A, B, and carry-in. They're connected to the power supply bus. And there's one, if you went ahead and paused the video and built this once I told you the schematic and found that it didn't work, you would be correct. You probably built it exactly the way I told you, but I made a mistake earlier in this tutorial. The 3 10K resistors going to ground, I told you put one of them in pin 1 of the exclusive OR gate going to ground, put one of them in pin 2 of the exclusive OR gate going to ground, and put one of them in either pin 3 or 4 going to ground. But that was incorrect. You were actually supposed to plug the resistor from pin 5 of the exclusive OR gate to ground. That would be that connection between the exclusive OR gate and the AND gate that you want. I can't exactly remember what I said in the beginning of this tutorial, but in case I didn't tell you, these resistors, the purpose of them, we might or might not use them when the computer is actually complete. The purpose of them, though, is when we're testing that the full adder works, to pull the pins low once we disconnect power from them. Otherwise, the pins will just be floating and you'll be getting readouts on these LEDs that are incorrect. So that's all they're there for now. And yeah, I think that was the only other thing I meant to tell you. But so I have the power supply plugged in, and let's go ahead and test this. When we hook up one of the inputs to power, it doesn't matter which one, you'll see the sum LED turn on, which is the one right here. See, it turns on there. I'm hooking it up to input A. I'm hooking it up to input B. And now the carry-in. That's fairly straightforward. Now I'm going to hook up two inputs. One to input A, and one to the B, and then the carry-in. When I supply power to B, if you notice, the sum turns off, and the carry-out turns on. And then the same thing when I supply power to the carry-in. The sum turns off, and the carry-out turns on. Now I'm plugging this wire into pin B, so now I'm going to test with 3 outputs. We should see both LEDs turn on if we built this properly, and we did. So, as you can see, the arithmetic logic unit that we just... Sorry, I'm getting... not plugging this wire in properly. As you can see, the arithmetic logic unit that we created does... it's only a full adder for now. We need to string the carry out of one to the carry in of the next, but for now you can see that it is working properly. When you build, the reason why I did the layout like this with the exclusive OR gate, the AND gate, and the OR gate is so I could put another AND gate here and another exclusive OR gate here. And you notice we only used this side of the integrated circuits. There are still 2 AND gates here, 2 exclusive OR gates here. So when you construct this and fill the breadboard with integrated circuits, you should have something like this. You'll have exclusive OR gate, AND gate, OR gate, AND gate, exclusive OR gate. This here is just another full adder going to the other OR gate on this side of the OR gate chip. But the wiring is a little bit different because, well, it's the exact same wiring if you go from pin to pin, but the wires need to be different lengths because you're kind of working backwards. So pin 1 of this to pin 2 of this is you know what? Actually, just forget what I just said. You know what? I don't even know. I'm not even making sense to myself. So if you just copy the exact connections you made, pin 1 of this to pin 2 of this, pin 2 of this to pin 1, and so on, and you just copy that up here. Also make another full adder here. Sorry, you can't even see that. Here, and then here. You can go ahead and string the carry out of one to the carry in of the next, and then do that with 2 breadboards, and you'll have 4 on each breadboard, which will be 8 full adders. And if you string them together, you will have your arithmetic logic unit complete. So I'm going to go ahead and do that, and then I'll show you the results I get, and it'll be pretty cool. And actually, change of mind. I am going to post that in the next tutorial, so thanks for watching, and I hope you enjoyed this video.